Hi GeoH, this is Unit 3, Lesson 7, and today we're going to do some more work with parallel lines. So the top right here is just a summary of some things that we've learned so far. The first one is that if I have two lines that are parallel and they're cut by a transversal, the alternate interior angles are congruent and the corresponding angles are congruent to each other. So just to remind you, alternate interior angles would look like here. Oh, that was kind of hard to see because it's so tiny. But right here and here, they're interior, they're in between those parallel lines, and they are on opposite sides of that transversal, where corresponding angles are sort of matching up. They're corresponding there in that exact same spot. Another thing that we know is the sum of the measures of all three angles of a triangle is always equal to 180. That's something you probably already knew before, but we proved it in the last unit. And the exterior angle of a triangle is the sum of the remote interior angles. So that one we didn't talk about last time, but we're going to talk about right here in exercise 1. So as a result, an exterior angle must also be greater in measure than either of its two remote interior angles. All right, so a triangle is shown below with its sides extended. All angles have measures as shown. Calculate the value of the exterior angle at each vertex and verify that it is the sum of the two remote interior angles. So here's what this says right here. Angle 1 is an exterior angle. It sits outside of the triangle. It's equal to the sum of the two remote interior angles. So by remote interior angles, I mean the ones that are furthest away from angle 1. So angle 1 is equal to 63 plus 83. Okay, so that equals 146. All right, so angle 1 is 146. Now, let me just sort of double check right here. Look at the 34 and the 146. They form a line. That means they need to equal 180. And look, they do in fact equal 180. So the fact that these two form a line and they equal 180 is one way to find angle 1. And the second way to find angle 1 is that it is an exterior angle. It's equal to the sum of those two interior angles. Well, let's look at angle 2. Angle 2 is also an exterior angle. Let me erase some of these highlights right here. So angle 2 is an exterior angle. I'm going to grab a different color. So angle 2 is an exterior angle. It's equal to the sum of the two interior angles of the triangle that are not next to it. That's what I mean by remote interior angles. So angle 2 equals angle the 63 plus the 34, and that equals 97. Well, let's see if that works out. Is 97 and 83 equal to 180? Because they form a linear pair. They form a line. And 97 and 83 is 180, so perfect. And the last one that we have is, and let me get my eraser out, angle 3 right here, that's an exterior angle. It equals the two remote interiors, so the two interior angles that are furthest away from it. So it equals 83 plus 34. And 83 plus 34 is 117. So this equals 117. And let's double check. What's 63 plus 117? It's 180. Okay, so that's a property. The exterior angle equals the sum of its two remote interior angles. So we now know what properties arise when we know two lines are parallel, but it's also important to know how to prove two lines are parallel. It's actually just going to be the opposite of the two theorems that we've already looked at. So lines will be parallel if any pair of corresponding angles are equal to each other. So if I have two lines, and if I tell you angle 1 is congruent to angle 2 and they happen to be corresponding angles, then boom, the lines are parallel. And conversely, if I have two lines and I tell you that the alternate interior angles are congruent, then that makes the lines parallel. So normally we say the lines are parallel, the alternate interior angles are congruent. I'm just doing the reverse. If the alternate interior angles are congruent, then that makes the lines parallel. So this is one way how we can prove that two lines are parallel to each other. All right, so we will prove the first theorem using an indirect method of proof. So we will assume that the two lines that have equal corresponding angles are not parallel and see what happens. All right, so an indirect method of proof is sort of proving, we start with the opposite and we prove that that actually can't be, there's a contradiction, so therefore it shows what we're trying to prove. So, in the following diagram, non-parallel lines M and N have been cut by transversal R to form two congruent angles, angle 1 and angle 2. So angle 1 and angle 2 are congruent to each other, or this is the indirect method of proof that we're doing. Why does this scenario contradict what we know from above about the exterior angle of a triangle? Because remember that angle 2 is the exterior angle of a triangle. Angle 2 should actually be equal to angle 1 and angle 3. So what's the contradiction? Since angle 2 is the exterior angle of triangle ABC, it equals angle 1 plus angle 3. Now, if it's equal to angle 1 and angle 3, it cannot be equal to angle 1 by itself. So it must be greater than angle 1. But we were told it equals angle 1. So there's my contradiction. But we were told it equals angle 1. So it can't be equal to angle 1 and at the same time equal to angle 1 and angle 3. It's not like angle 3 is non-existent. So what does this tell you when two corresponding angles are equal? So when two corresponding angles are equal, the two lines crossed can never intersect and must be parallel. So when two corresponding angles are equal, then the two lines can neither intersect and must be parallel. So the two lines can't intersect, we'll say, can't intersect and must be parallel. All right. Flip over. We have a couple more examples on the next page. We got 3 more examples. So in example 3, in the diagrams below, P and Q are cut by transversals. The angles are marked as shown. Explain why P and S must be parallel to each other. So please remember the angles of a triangle equal 180. Okay, so let me add the two angles that I know, the 74 and the 43. Subtract it from 180. So 180 minus 117 is 63. Okay, so this angle right here must be 63. Now, if this is 63 and the one on top is 63, then those are corresponding angles, therefore the lines must be parallel. Okay, so since the two corresponding angles are congruent, then the lines are parallel. Then P is parallel to S. All right, in exercise 4, I know that A is parallel to B and B is parallel to C. I want to prove that A is parallel to C. And I numbered the angles there for us to help us out. If A is parallel to B, okay, so if A is parallel to B, then what do you know about angle 1 and angle 2? Think about what kind of angles those are. Angle 1 is congruent to angle 2 because they are alternate interior angles. And if B is parallel to C, then angle 3 and angle 4 are congruent because those are alternate interior angles. So let's do a little substitution right there. Well, actually, one more thing I got to tell you. What about angle 2 and angle 3? Angle 2 and angle 3 are congruent, not because of the parallel lines, but because they are vertical angles. All right, so if 1 is congruent to 2, 3 is congruent to 4, and 2 is congruent to 3, then I can say that angle 1 is congruent to angle 3 by substitution. Let me show you the substitution. I'll highlight it for us. So right here, okay, I basically took these two. 1 is congruent to 2 and 2 is congruent to 3. Since 1 is congruent to 2, I took angle 1 and I substituted it in for angle 2, and I said that 1 is congruent to 3 by substitution. And also, angle 1 is congruent to angle 4 by substitution. Where is that substitution? So 1 is congruent to 4 because now I have 1 congruent to 3 right here. Let me get another color. I'll get this bluish. Is that dark enough? That won't be dark enough. Let me get the purple. 1 is congruent to 3 right here. Okay, and 3 is congruent to 4. I can say that 1 is congruent to 4 by substitution. And if 1 is congruent to 4, look at 1 and 4. 1 and 4. Sort of like ignore angle B in the middle. Not angle B. Ignore line B in the middle. 1 and 4 are really just alternate interior angles. So 1 and 4 are congruent to each other. Then A is parallel to C. All right, 1 and 4 become my alternate interior angles. You sort of ignore that other parallel line in the middle, B. Okay? As we've seen, last problem, parallel lines and triangles are linked through various principles, including the most famous link of the 180 sum, the one we proved yesterday. We should be prepared to use parallel line properties in proofs involving triangles and vice versa. So we're going to do a little proof here. In the triangle below, AC and DF intersect at E. We would like to prove that AD is parallel to FC. State all pairs of angles if proved equal that would let you conclude that AD is parallel to FC. So I'm going to number my picture with some numbers here. So I'm going to call this 1. I'm going to call this 2. I'm going to call this 3. I'm going to call this 4. I'm going to call this 5. And this 6. I got one more. All right, sorry about the dog barking. So the ones that would help me to prove the lines are parallel. If you could prove that angle 1 is congruent to angle 2, or if you could prove angle 3 is congruent to angle 4, that would make the lines parallel because they are both alternate interior angles. And if the alternate interior angles were congruent, then the lines would have to be parallel to each other. How can you prove that these angles are congruent? Well, let me prove the triangles are congruent, just like I did. If you prove the triangles are congruent, then the angles are congruent by our CPCTC. Corresponding parts of congruent triangles are congruent. So I'm going to prove the triangles are congruent, then I can say those corresponding angles are congruent by CPCTC, and if the angles are congruent, then the lines have to be parallel to each other. All right, so that is my plan of attack right here. So I'm going to start off with my given. The given is just that AC and DF bisect each other. But that's a lot of information. If they bisect each other, they cut each other in half, which is great. So since they bisect each other, they cut each other in half. So FE is congruent to DE, and AE is congruent to EC. So FE is congruent to ED, and AE is congruent to EC. Definition bisector. A bisector divides a segment into two congruent segments. Now I'm trying to prove the triangles are congruent, so I don't know anything about angle 1 and angle 2 yet. I don't know anything about angle 3 and angle 4 yet. But I do know something about angle 5 and angle 6. Remember, that's something that you have to look for on your own. You have to look to see if they share a side, which in this case they don't, but you have to look for vertical angles. So angle 5 and angle 6 are vertical angles. Well, at this point, I can say my triangles are congruent to each other by side angle side. So triangle CFE is congruent to triangle ADE by side angle side. Once my triangles are congruent, then the rest of the corresponding sides and angles are congruent. So I can say 3 and 4 are congruent or 1 and 2. It doesn't matter which pair I pick because both of those are alternate interior angles. So I'm going with angle 1 and angle 2. So angle 1 and angle 2 are congruent, not because they're alternate interior, they're congruent by CP/CTC. And now since they're congruent and they happen to be alternate interior angles, that's what makes AD parallel to FC, which is what I wanted to prove. Okay, if the alternate interior angles are congruent, then the lines are parallel. And that's my proof. So I proved two lines are parallel to each other. All right, I do that by showing that the alternate interior angles are congruent or the corresponding angles are congruent. And how did I get that? That in this particular problem is I first proved that the triangles are congruent. So we will do some more work with parallel lines.